Welcome to a new course, Software Metrics and Quality Assurance. Today we will see just a overview of few terms that are related with this subject. We all know that software engineering. What is software engineering? Software engineering is an engineering branch associated with development of software product using well-defined scientific principles, methods and procedures. As we know, uh, it encompasses so many things that all come across this software engineering. There is an application, we need to select some language, we have to write the script, and there is updating, there is a network, and we have to install it, we have to download, there are bugs, there are so many problems, so many things, they are all associated with this software engineering. So when we talk about the software, do we know that there are so many problems, they are all related with the software. So technically speaking, for more than 50 years, software has been a troublesome discipline. For more than 50 years, software has been a troublesome discipline. Software's problems are numerous and include cancellation, litigation, cost overruns, schedule overruns, high maintenance cost, and low levels of user satisfaction. There are so many problems. The problems with software occur more than often than not. Many companies' research indicate that more than half of large software projects will encounter some kind of delay. It may be overrun or failure to perform when deployed. Right from scratch, they are developing the script. We don't know, there are so many problems till the final implementation. But software does not have a troublesome as it has been. Some complex software projects do achieve their delivery schedules and cost targets and behave properly when used. So problems are there and we have to find the solutions also. So it happens that main factors leading to the software success, just for our simplicity, I have written as success of the software, that is directly proportional. This sign indicates directly proportional to the quality of the software. The main theme what we are learning in this course is what is the quality metrics, and how we are going to assure this quality. So it happens that main factors leading to the software success are easily identified when side-by-side comparisons of similar projects are performed, where one set was successful and other set was troublesome. The successful software projects achieve excellence in software quality control, and they are able to do this because of excellence in software quality measurements. I mean to say, when we talk about the success of software, it is directly proportional to what quality it has been built. If the quality is good, then only there will be a success in the software. So one more thing, one of the researcher, Dr. Joseph Juran, one of the key founder of the modern quality management and engineering, describes life behind the quality dies. What he tells, the life behind the quality dies. What does it mean? As society becomes more reliant on technology, failures of that technology have increasing adverse impacts. Quality helps to isolate society from these dangers. There are so many risks and there are so many dangers. When there is an improvement in the quality, obviously we are going to be the software will become successful. Otherwise, the life behind the quality, it dies. Means if there is a quality, then only the software will be alive. This role of quality in software development certainly rivals that of business competitiveness, and gives another compelling reason to understand and various ideas we have to apply, so that we have to increase the quality of the software. Next we will see the different eras. Before just going into the subject, what quality assurance is, what are its metrics, let us have a brief introduction about the various software eras. Different eras are there. So as the scale is shown, 1950, 1960, 70, 1980, 1990, 2000, 2010, and beyond this 2010. So looking at the software engineering from a historical perspective, the 1960 and earlier could be viewed as the functional era. They are called as the functional era. The 1970s, the schedule era. In 1970, we call it as a schedule era. The 1980, the cost era. After 1980 to 1990, we have seen is the cost era. And the 1990s and beyond, the quality and efficiency era. Means after all, from the previous experiences, we came to know that quality is much more important, and this era from 1990 we are calling it as a quality era. Means we are much more focused on the quality of the software. So in 1960, we learned how to exploit information technology to meet the institutional needs and began to link software with daily operation and institution. Means before this 1990, it was very initial stage. What we did, we learned how to exploit information technology to meet institutional needs and began to link software with daily operations of institution. When we came to 1970, so as the industry was characterized by massive schedule delays and cost overruns, the focus was on planning. See, when they have given some project, it has to be completed within that deadline. So the focus was on planning. That's why we are calling it the scheduling era, isn't it? So in 1970, as industry was characterized by massive schedule delays and cost overruns, the focus was on planning and control of software projects. Phase-based life cycle models were introduced. We will come across so many models in the future classes, like the mythical man month emerged. In 1980, the hardware cost continued to decline. I have not shown the hardware cost and software cost. They both the graph was increasing, but at a certain point in 1980, in that point, so the cost of the hardware was not simultaneously increasing with the software. It went down because of so many technologies they developed in the field of the hardware aspect. In 1980, hardware costs continued to decline and information technology permeated every facet of our institution and became available to individuals. As competition in the industry became keen and low cost application became widely implemented, the importance of productivity in software development increased significantly. Various software engineering cost models were developed and used. In late 1980, the importance of quality was also recognized. So these we started from this era, just from the scratch development of few applications. We focused on functions, we focused on the planning like scheduling, we focused on the cost, and finally we came to know that the life of the software, it depends upon the quality. So after 1990, we switched our focus on the quality of the software. So people recognized that the importance of quality was recognized. In 1990 and beyond is certainly the quality era. With state-of-art technology now able to provide abundant functionality, customer demand high quality. Demand for quality is further intensified by the ever-increasing dependence of society on the software. The society was dependent upon the quality software. Billing errors, large-scale disrupted telephone service, and even missile failures during recent wars can be traced to the issue of software quality. So it is not just that the quality matters for fun, simple application. It matters even for the so many failures in the billing, the failures, the missile failure, and there are so many issues that are linked with the bugs or the lacunae in the quality of the software. So in this era, quality has been brought to the center. In this era, the quality has been brought to the center of software development process. From the standpoint of the software vendors, quality is no longer an advantage factor in the marketplace. It has become a necessary condition if a company is to compete successfully. To stand in the market, the software should have the quality. the customer should be satisfied with the quality, then only the software runs in the market. We have two factors. Starting in the mid 1990s, two major factors emerged that have proved to have an unprecedented impact on not only software engineering, what software engineering we have discussed in the first slide itself, not only software engineering but also on global business environment. So there are two major factors. They have proven to have a great impact on the global business environment. The first is business re-engineering for efficiency, and second is the internet. So there are two factors. Software development has to be more efficient, and quality level of the delivered product has to be high to meet the requirements and to be successful. This is especially the case for mission critical applications. The adverse impact of poor quality is much more significant and at a much more wider scale. The quality dikes the software is supposed to provide are never more important. Means if the quality fails, the software fails. These factors will continue to affect software engineering for many years to come during this new millennium. So after this term, one more important term, that is a measurement. What this measurement is? So measurement plays an important, a critical role in effective and efficient software development, as well as it provides the scientific basis for software engineering that makes it a true engineering discipline. So it was important term. That's why I have written measurement. We will see, we will come across all these things in detail in the next classes. Measurement plays a critical role in effective and efficient software development, as well as it provides the scientific basis for software engineering that makes it a true engineering discipline. Thank you.